Hey everyone, it's Coach K. We're going to be doing lesson 5.1 and 5.4 triangles. So let's get started. Triangles can be classified by their angles, and their sides. Okay. So if we're classifying by the triangle, the first one we're going to talk about is what a right triangle is. That means it has to have exactly one angle that equals 90 degrees. So x equals 90 degrees. Next one is an obtuse triangle. An obtuse triangle it has to be between 90 degrees. So 90 degrees is less than x, which is less than 180 degrees. So that means it has to be between 90 and 180 degrees for this angle right here. An acute triangle has to be between 0 and 90. So all the angles will be less than 90 degrees. An equilateral triangle means that all the angles are going to be equal to 60 degrees. A scalene triangle means that no angles are the same. So scaling can be scary because nothing is the same. Isosceles, you think about your eyes. So that will be two angles that are, or two sides that are the same. So these two sides are the same. Equilateral triangle means equal. So then you have three that are the same. So all of the sides are the same. All right, so in problem number 1, we're going to classify the triangle by its sides and its angles. The sides, remember, are scaling. Are they all the same? Then or is it isosceles where two sides are the same, or is it an equilateral? Then we'll establish, is it a right triangle? So let's do sides first. So the first thing that you're going to do is to find the side, you need to do the distance formula. So we're going to do x2 minus x1 squared plus y2 minus y1 squared. So we're going to substitute in and get our answer. So on this one right here, on O and P, O to P, we're going to be using the points 0, 0, and -1, 2. So we're going to substitute in. So we have our x2, which is a -1, minus 0 squared, plus our y2, which is 2 minus 0 squared. And when we work that out, we get the square root of 5. So let's do the second one. O and Q. So we're still using 0, 0, and 6, 3 this time. So when I work it out, it would be 6 minus 0 squared plus 3 minus 0 squared. So in reality, this would be 36 plus 9. And so it would be the square root of 45. Okay, so right now we know it's not an equilateral triangle because there's two sides that are not the same. So let's look at the last side, see what that one is. So I have -1, 2 for P, and then I have 6, 3 for Q. So we're still going to put it in there. So that gives me 6 minus a -1, a negative and negative make a +1, squared, plus 3 minus 2 squared. So that gives me 7 squared, which is 49, and then 1 squared, which is 1. So this right here gives me the square root of 50. So we know for sure it's going to be a scaling triangle. Okay. Because none of the sides are the same. So it is a scaling triangle. Okay, now we have to establish if it's a right triangle or not. So right here, remember if it's a right angle, where do you think the right angle is going to be? Oh, at O. So we need to find the slope for each one. So we need to find the slope from P to O, and we need to find the slope from Q to O. So our slope from P to, or O to P is up 2, left 1. So it's a negative 2 over 1. Then let's find slope from P to Q. P to Q is up 1 over 2. So up 1 over 2. What's the relationship with the two? If it's the opposite reciprocal, then I can say, therefore, it's perpendicular. So it is also a right triangle. All right, for problem number 2 and 3, it says the sum of the measure of the interior angles of a triangle is 180 degrees. In the blank, please put 180 degrees. All right, so if we're doing number 2, it would be part plus part equals whole. So then that would be x, because we don't know what angle 1 is, plus 30 plus 40 equals 180. So I combine terms. So I get 70 equals 180 minus 70 on both sides, inverse operations, x equals 110. So because the measure of angle 1 is 110, this one is a obtuse triangle. All right, let's look at number 3. It says find x and the measure of the acute angles. So both angles. Okay, so we're still going to do part plus part equals whole. All right, so we have 2x plus x minus 6 plus 90 equals 180. So I have 3x plus 84 equals 180. I'm going to subtract 84 on both sides. 3x equals 96. I'm going to divide by 3. X equals 32. So my x is 32. Now what is the angle measures? So if I look at this one right here, it would be 32 times 2, which is 64. And if I do this one, it is 32 times, or minus, 32 minus 6, and that gives us 26. And so when you add all three of them together, the 90 plus the 64 plus the 26, that should give you 180 degrees. All right, the sum of the measure of the exterior angle of a triangle is equal to the sum of the measure of the two non-adjacent interior angles. So basically what this is saying is that this angle and this angle here, they have to add together to give you this angle. So it is the measure of angle 1 equals 53 plus 53. So when you add those two together, that gives you 106. If you don't remember how to do this, then what you can do is add the 53 and 53, subtract it from 180, and you can get this angle right here. Then both of these two angles add up to 180. So that's another way. So let's look at the next one right here. So we have, if we're doing this, we're going to have x plus 70 equals 2x minus 5. So you add these two angles here, and they give you this outside angle. That's what they're going to be equal to. So get your x's to one side, get your numbers to the other side. So I have 75 equals x. So this angle right here would be 75. This one right here would be 2 times 75 minus 5, which would give us 145. All right, so the two sides that are congruent are BA is congruent to line segment CA. Those are called legs. So I have a leg here and I have a leg here. The angle that is formed by the two legs is called my vertex, which is angle A. The third side down here at the bottom is called my base. So the third side, my base, is line segment BC. Then I have my two base angles, so I have B and C. Angle B and angle C are congruent because they're across from your legs. So let's talk about the base angle theorem. All right, so if this side is congruent to this side, we can say that the angles across from those two sides are also congruent. So I can say that B is congruent to C. Because if the measure of the sides are the same, the angles have to be the same because the sides are the same. So the converse of that is, if the two angles are the same, we can go the opposite way and say the two legs are the same. So that means this would be congruent to this. So I can say that BA is congruent to CA. All right, so let's apply what we just talking about. If angle B is congruent to what? Yes, angle C. So, angle C. If we know that angle B is congruent to angle C, remember, we can go opposite and make our legs congruent to each other. So we can say that CA is congruent to BA. What do you notice in this problem right here? What is the same? The same as angle A. So angle A is your vertex angle. So remember, the congruent symbol means that it wants a letter. If it is an equal symbol, it wants a number. So we have letters for those. Now let's solve for x. What do we know? This is part equals part. So we have 24 equals 3 times x plus 2. Remember, we're doing the distributive property. So we'll distribute the 3. 3x plus 6 equals 24. Going to subtract 6 on both sides. I have 18 equals 3x. We're going to divide by 3. X equals 6. So everywhere I see an x, I'm going to put a 6. So this side right here would be 24. So my x equals 6. A to B is 24. Technically, we didn't have to do anything at all because we already knew that the two sides are congruent. The measure of angle B, we have to do a little bit of work there because we know that angle A is a 90-degree angle. Okay. So since this is a 90-degree angle, remember it's going to be part plus part plus part equals whole. So let's go ahead and subtract the 90 on both sides. And that gives you 2x equals 90. Divide both sides by 2, x equals 45. So angle B is 45 degrees. So if angle B is 45 degrees, then that means angle C is also 45 degrees. All right, that's the end of our lesson for today. Have a great day.